Assalamu alaikum wa rahmatullahi wa barakatuh. Our new chapter is antiderivatives. Objectives: define the antiderivative or primitive of a function. State and use the properties of integrals. Integrate a function using the direct method of integration. Definition of antiderivative. Let small f be a continuous function and capital F be a differentiable function on an interval I. Capital F is an antiderivative or primitive of small f on I if the derivative of capital F prime x equal small f of x. Notation: capital F of x equal integral of small f of x dx. Example: in each of the following cases below, verify that capital F is an antiderivative of small f. Capital F of x equal x cubed plus 6x minus 1, and small f of x equal 3x squared plus 6. What we want to do, we make the derivative of capital F that's equal to 3x squared plus 6, which is equal to the small f of x. Then capital F is an antiderivative of small f. B. Capital F of x equal x ln x minus x plus 2, and small f of x equal ln x. Then we do the derivative of capital F of x. That's equal to u prime v plus v prime u, because here you have u dot v. That's equal to ln x, which is equal to the small f of x. Then capital F is an antiderivative of small f. Application: in each of the following cases below, verify that capital G is an antiderivative of small g. Capital G of x equal ex plus 2x plus 2, and small g of x equal ex plus 2. Pause the video, then solve. Solution: capital G prime of x equal x plus 2, which is equal to small g of x. Then capital G is an antiderivative of small g. Pause the video and show that capital G of x is an antiderivative of small g of x. Application: verify that integral of 5e5x plus 3x squared plus 2 dx equal e5x plus x cubed plus 2x plus c, where c is any constant. Pause the video, then solve. Application 3. Let capital F and small f be two functions defined respectively as capital F of x equal ax plus b e minus x, and small f of x equal x plus 1 e minus x. Find the real number a and b, knowing that capital F is an antiderivative of small f. Pause the video, then solve. Solution: integration properties. Let small f be a continuous function and capital F be a differentiable function on an interval I. Let k and L be two real numbers. Integral k times f of x dx equal k integral f of x dx. Integral f of x plus or minus g of x dx equal integral of f of x dx plus or minus integral of g of x dx. Integral of k f of x plus or minus L g of x dx equal k integral f of x dx plus or minus L integral g of x dx. We remark that when we have a constant number multiplied by the function, we can put the constant number outside the integral. And if we have a plus or minus between two functions, then we can distribute the integral over these two functions. Integral f prime of x dx is equal to fx plus constant. Since if we make the derivative of f of x plus c, we get f prime of x, and the derivative of the constant is equal to 0. Then the integral of f prime of x dx equal f of x plus constant. Then in any integral not bounded, we want to add constant. Since maybe before the derivation we have this constant. Now the derivative of integral f of x dx equal f of x. Integration technique, direct method. Rule 1. Integral ax plus b power n dx equal ax plus b power n plus 1 over a n plus 1 plus c. Then we apply this rule when we have an integral of the same form. Example 2. Integrate. Integral 2x plus 1 power 3 dx. Now we want to apply this rule, which is equal 2x plus 1 power 4. Then we divide by a times n plus 1, which is 4, plus the constant c. We get 2x plus 1 power 4 over 8 plus c. Integral v minus 2 power 7 dv. Now we apply the rule, then we get v minus 2 power 7 plus 1 over the coefficient of v is 1 times 7 plus 1. Then we get v minus 2 power 8 over 8 plus c. Integral 4 minus 3x power 5, which is equal to 4 minus 3x power 6. We add 1 to 5, we get 6 over the coefficient of x, which is minus 3 times 6 plus constant equal minus 4 minus 3x power 6 over 18 plus constant. We add the constant because if we make the derivative of the result, we get this function. The derivative of constant equal to 0. Integral dx. We have here 1 dx. What is the antiderivative of 1? What is the function of derivative equal 1, which is equal x plus c? E, x4 dx, which is equal x5 over 5 plus c. Integral 4u minus 9 du, which is equal 4 outside the integral, u minus 9, we add 1 to the power and we divide by the result. Then we have 4u minus 8 over minus 8. We simplify 4 and minus 8, we get minus 1 over 2. And we move u minus 8 from the numerator to the denominator, we get u power 8 plus c. Remember the rule of integral ax plus b power n dx, which is equal ax plus b power n minus 1 over a n plus 1 plus constant, where a is different than 0 and n different than minus 1. Application 4. Integrate. A. Pause the video, then solve. B. Pause the video, then solve. C. Pause the video, then solve. D. Pause the video, then solve. Oops, we can't solve this integral using this rule because here x is to the power 1 and here x is to the power 2. Rule 2. Integral 1 over ax plus b dx, which is equal to ln absolute ax plus b over a plus constant for a does not equal to 0. Here we put absolute value because the value inside the ln must be positive. Example, integrate. Integral 1 over 2x plus 3, it has the same form of this integral, then we can apply rule 2. Then the result equal ln absolute 2x plus 3 over 2 plus constant. Integral 5 over 5x plus 2 dx, which is equal 5 outside the integral. The integral of 1 over 5x plus 2 equal ln absolute 5x plus 2 over 5 plus constant. We simplify by 5, which is equal ln absolute 5x plus 2 plus constant. C. Integral 3 over v minus 2v dv. Here we decompose the integral into two integrals. The first one is integral 3 over v dv. We put 3 outside the integral, then we get 3 ln absolute v, because the derivative of ln v is 1 over v, and the antiderivative of minus 2v is minus 2v squared over 2 plus constant. Then the result is 3 ln absolute v minus v squared plus c. Application 5. Integrate. A. Pause the video, then solve. B. Pause the video, then solve. C. Pause the video, then solve. Oops! Here we have t squared plus 2, but the rule here is x to the power 1, but here we have the variable to the power 2. Then we can solve this integral by this rule. Rule 3. Integral EAX plus B dx equal EAX plus B over A plus constant for A different than 0. Example 4. Integrate. Integral of EX. Here we have A equal 1, B equal to 0. Then we get e power 1x plus 0 over 1 plus constant, which is equal to EX plus C. B. E minus x. Here we have A equal minus 1, B equal to 0. We get e minus x plus 0 over minus 1, which is equal to minus e minus x plus constant. Integral e 2u plus 3 du. Here we have a equal 2, b equal 3. We get e 2u plus 3 over a, which is equal to 2. We remark that here the variable is u. We multiply this function by du inside the integral, but here we have the variable is x. We multiply the function inside the integral by dx. Application 6. A. Pause the video, then solve. B. Pause the video, then solve. C. Pause the video, then solve. Rami or Mira or Amir. Application 7. Integrate integral 3 over 3x plus 2 squared dx. This 3 students solve this integral, each one in his own way. Now we want to find which one solve this integral correctly. Here Rami used the rule number 2, but it's not this case. Then he used the wrong rule. Here Mira used the truth rule, which is rule 1, but here he forget the coefficient of x here in the denominator, then it has a wrong result. But Amir used the rule 1 correctly in all the steps, then he has the true method. Assignment, summary,